Hey guys, it's Ms. Marfleck here. We're going to get ready together to go over our first quiz review for trigonometry. Now we've covered a lot of different topics, and this should be a really good foundation of this trigonometry. If you don't do well in the quiz, I want you to kind of go back and look at all the material because we will also be having a test on this material. So I just want to let you know, going forward, we're going to be learning more trig, and then what we learned here will be inclusive in the test. Now, I'm hoping this video will go quick because I pre-wrote most of the questions. So throughout the video, if you have to pause so that you can catch up in your notebook, go ahead and do that. For those of you who maybe just want a quick review, it's okay to not write all this down, but keep in mind that your quiz is open notes and you have 5 minutes for each question. So those 5 minutes should be more than enough time to read the question, think about the question, flip back through your notebook, and maybe find a similar example or read a definition because there is a lot in this quiz, a lot. All right, let's jump in and get started. The first thing we did together was 30, 60, 90, 45, 45, 90. Those were our two special right triangles. We solved for the missing side. Then we learned SOHCAHTOA. We did degree and radian conversion, but we did it after all these topics that are coming up. But I put this first because all these topics underneath you're going to have to be able to do in degrees and radians, and that's drawing angles in standard position, seeing whether an angle is a quadrantal angle, and then seeing two angles are coterminal or solving for a coterminal angle, and then solving for a reference angle. And then the last thing that we did together was a unit circle, and I can only ask you questions about the basics of the unit circle. What's the radius, what's the coordinate point at this angle, and things like that. And we're going to be seeing more of the unit circle going forward. All right, we're going to jump into our first question, and it's going to be based on our 30, 60, 90, 45, 45, 90, and our goal here is going to be to solve for the missing sides. And then here's going to be our triangle. Now, it's really helpful to use the rules here if you'd like them, but you first need to be able to identify what is your long leg and what is your short leg. Well, the short is between right angle and 60, and the long is between right angle and 30. So you can start off by writing your formula that long leg is equal to square root of 3 times your short leg. And I have my long leg, that's my 3 square root of 3, and what I'm looking for is that short leg, which is my y. And now my goal is to solve for y by dividing both sides by square root of 3. And then you could see here that y is equal to 3. And then now that you have the short leg, it's easier to find the hypotenuse once you have the short leg, because our formula is hypotenuse is 2 times our short leg. And our hypotenuse here is x, and our short leg was y, but now we know it's 3, so that hypotenuse there is 6. And then double check your work, make sure that hypotenuse is always your longest leg. And we're not going to do a 45, 45, 90 triangle. That one's a little easier. Keep in mind that those legs are equal in that triangle, and you have the square root of 2. It'll also be a good idea to write down your two triangles while you're taking your assessment. All right, moving on to our next type of question, that's going to be SOHCAHTOA. We use our SOHCAHTOA, and SOHCAHTOA is the ratio between angles, and then the ratio of their legs. And sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Keeping in mind, adjacent touches the angle, and opposite is usually across, and hypotenuse is the biggest. So I can see right away that hypotenuse is 25 here because that's the biggest number. So now here we are, sine of x. X is our angle, and sine is opposite over hypotenuse. So this is 7 over 25. Now we're moving on to cosine. Cosine is adjacent over hypotenuse, and that's 24 over 25. And then tangent of x, opposite over adjacent, and we have 7 over 24. And then now we're moving on to a new angle, theta. Keep in mind these angles can be represented in many different ways. They can be capital A, B, C, along with theta. We have our other letters, maybe beta, you could see an alpha. Just know that this symbol in here is your angle. All right, now sine of theta is opposite over hypotenuse, that's 24 over 25. Cosine of theta is adjacent over hypotenuse, that's 7 over 25. And then tangent theta is opposite over adjacent, and that's 24 over 7. And then there's our SOHCAHTOA. After we did SOHCAHTOA, one of the next things that we covered was converting between degrees and radians. We had a conversion factor, which also would be a good thing to have handy with you on a sheet of paper, along with your two special right triangles while taking your assessment. When we go from radians to degrees, we multiply by our conversion factor, which is pi and 180 up in the numerator, 180 over pi. And then here now we have pi over pi will become 1. And then I could do 180 divided by 4 in the calculator, or, you know, just doing some quick math here, I can cut 180 in half, and then I can cut 90 in half again. And then you'll definitely have a calculator, and in your calculator you should be doing 45 times 7. Here we get 35, 28, add the 3, this is 315, and then that's 315 degrees. And then now you know how to like kind of check your work, because we've drawn these angles in standard position, so you should know, looking at this angle, that it is past 4 pi over 4, 3/4 of the way, and it's lying in quadrant 4, so you're looking for a degree angle that lies in quadrant 4. All right, now we're converting from degrees to radians, which means we have to multiply by pi over 180. Degree and degree becomes 1 and cancels out. Now we're working in rads. We can divide by 10, and then I like to simplify along the way, you'd like, and then I can see here that I can divide numerator and denominator by 3, and that's going to be 5 pi over 6, and then there's nothing else I can simplify, and there's my angle. And then we could see here that this lies in quadrant 2, and 5 pi over 6 is not at 6 pi over 6, so that also lies in quadrant 2. All right, after we did converting between degrees and radians, or one of the next topics that we did with our angles was starting with drawing in standard position. Now, with the drawing in standard position, now I can't ask you to draw it with a multiple choice question, so I can give you a drawn angle and, you know, maybe ask you which one, give you a picture, maybe ask you which angle is this, or ask you what quadrant an angle is in. So here we are, we're going to draw this in standard position, and the first one is negative 120 degrees. Keep in mind, positive angles open up this way. Okay, go in this direction, and negative angles open up to quadrant 4. So this is going to make this axis negative 90, and this is going to make this one negative 180. So if I want to draw negative 120, I pass negative 90, and then I'm somewhere in quadrant 3. So my answer here would be quadrant 3, so I could ask you what quadrant is negative 120 degrees in. All right, now 2 pi over 3, we know that this is 0 rads, this is pi over 2 rads, this is pi, 3 pi over 2 rads, and 2 pi rads. Maybe this is something that you just have with you while you're also taking your assessment if you can't know or memorize all the axes. All right, and then now we're 2/3 of pi, okay? So we're not at pi yet, we're not 3 pi, and we passed a half because that would be 1.5 pi over 3. So here we are in quadrant 2. And then now for this last one, number 7 pi over 4, well, we open up in the positive direction. We pass 4 pi over 4, right? 3 over 2. This would be 6 pi over 4, and then 7 would be right in the middle here, and that's going to be in quadrant 4. Now, you don't need to use Roman numerals, okay? I will also put the 3, the 2, and the 4 next to it, but usually with quadrants we do use the Roman numerals. All right, and then the next thing we did was identify whether or not an angle is a quadrantal angle. Oh, and I should have said the definition, but in standard position that means we have our vertex at the origin and our initial side lies on the positive x-axis. All right, now here we are, quadrantal angles. A quadrantal angle is an angle that lies on an axis, whether the x or the y-axis. So this is just a very simple yes or no, or maybe I can do a drop-down menu and say select all of the quadrantal angles, and you can select them all. Negative 90 degrees lies on this y-axis, so this is a yes. Pi lies on the x-axis, so this is a yes. 190 degrees lies in quadrant 3, so this is a no. And then 4 pi over 3 also lies in quadrant 3. This one is a no, so that one was pretty quick. Quadrantal angles. All right, and then after quadrantal angles, we talked about coterminal angles. We said 2 angles were coterminal if they share the same initial and terminal side, but they're just on different, or might be just on different revolutions. So we're looking here for one positive, one negative. Now, when we did these coterminal angles, I said there's a few different ways I could ask you this question. I could say, give me 2 negative, give me 2 positive. Are the following 2 angles coterminal? Are the following 3 angles coterminal? Which pair are coterminal? So really focusing on knowing that definition and maybe just not memorizing this style of question from the review. All right, so here we are. We're looking for a positive and then a negative, which means I'm going to take 210 degrees and I'm going to add 360 degrees to find that positive. I got a 0, I got a 7, and I got a 5. 570 degrees is my positive angle. And then now I want to take 210 and subtract 360, which means I have negative 360. And then you can use a calculator for this. Ms. Marfleck's going to do it on paper, though, and that's going to be negative 150 degrees. If you're not good with the rules and maybe just doing some integer addition, subtraction with the negatives, no worries. Use a calculator. Do 210 minus 360, and you're going to get negative 150 degrees. And then there's our one positive, and there's our one negative. Now we're moving on to number 13 with a radian. With a radian measure, we do have to count that 360 degrees is 2 pi. So we're going to be adding 2 pi here, and I need a common denominator. So I'm going to convert 2 pi to 8 pi over 4, and then that's going to be the same as 2 pi, adding a revolution. And then I could just add those numerators across, and the denominator stays the same, and we say that 11 pi over 4 and 3 pi over 4 are coterminal angles. Be very careful. Some people add pi because they think that's a full revolution. No. Remember, pi is a half circle. Okay, it's not a full revolution. So that might be like a trick question. I could say I can give you, which angle's coterminal to 3 pi over 4, and definitely one of the choices would be 7 pi over 4, and that's not an answer. 11 pi over 4 would be your answer. And then now we're going to subtract a revolution. We're going to subtract that 8 pi over 4. And now we have 3 minus 8 is a negative 5. And that's going to be over 4. And we can say that 11 pi over 6 and negative 5 pi over 4 are coterminal. And they're also coterminal with 3 pi over 4. So once again, coterminal angles share the same initial and terminal side. All right, we're nearing towards the end here, and one of the last thing we did with angles was finding a reference angle. We talked about how reference angles are positive acute angles always formed with the x-axis. Since they're positive, you can think of it as a distance because it has no direction. It's not positive. It can't be a negative angle, so you can always think of it as a positive distance. So I like to ask myself, what is the distance of this angle to the nearest x-axis? So when I'm looking at this angle 310 degrees, well, I know 310 degrees is in quadrant 4, and I have to think about, okay, well, in quadrant 4, I'm really close to that. I'm really close to this x-axis. So how far is 310 to the nearest x-axis? Well, it is 50 degrees because that nearest x-axis would be 360. So I'm 50 degrees away. So that would be my reference angle here. 7 pi over 6, we pass 6 pi over 6, and here we are, and we're one more past 6 pi over 6. So my nearest x-axis is this one here, and I'm pi over 6 in quadrant 3 past that axis. That's my distance to the nearest x-axis. And then 5 pi over 3, a lot of people have some trouble drawing this one. This is 3 pi over 3, and I need 5, so I have to go 2/3 of the way to my next pi. This would be 6 pi over 3, you can think about. This would be 3 pi over 3. So 5 would be here in quadrant 4. And then I'm near this x-axis, so I am pi over 3 away from that axis. Notice how they're all positive, and notice how they're all acute, less than 90 degrees or less than pi over 2. A 6 is less than a half, and a third is less than a half. All right, and then here's the end. Now, we did do the unit circle, and I did put up some notes with the unit circle, and you should have this with you while you're taking your assessment. Now, I don't expect you to memorize it yet, because when you get to pre-calc, you're definitely going to need to know it. But for right now, we're doing this remote learning, so everything's open notes. So you need to have this with you. We went over the unit circle. We saw how, we converted between radians and degrees, and then we were able to fill in these coordinate points. So I can ask you something like, what is a coordinate point on the unit circle for each of the following angles? And I can ask you for 150 degrees. All right, so you take a minute, and maybe you find 150 degrees. Okay, here's 150 degrees, and this would be my coordinate point here. Negative square root of 3 over 2 is my x coordinate, and then 1/2 is my y coordinate. So I can ask you, instead of maybe what is a coordinate point, oh, did I miss the word point here? What is the coordinate? Coordinate's fine, but it should I mess up my notes? I'm gonna do it. Okay, we're gonna put point in here. Just when I made no mistakes and my notes were looking beautiful. But anyway, this directions say what is a coordinate point, but I can ask you what's the x coordinate or what's the y coordinate, and then you need to be able to locate that on the unit circle. All right, we made it to the end. Here's the last question. Locating 11 pi over 6 on the unit circle and finding that coordinate point. Okay, 11 pi over 6. Where's that? Where's that? Where's that? Oh, here it is in quadrant 4. All right, and then my coordinate point here would be positive square root of 3 over 2 and negative 1/2. And then there is my answer. All right, make sure you do some studying. Make sure if you're struggling, you look at some past videos. Make sure you have your 2 special right triangles with you while you're taking the assessment. You know, your degree and radian conversion factors, make sure you have your definitions with you, and make sure you have a copy of the unit circle, because you do have 5 minutes for each question, so you could take your time and kind of flip through your notes. But if you don't have this stuff written down, you don't have enough time to go back and look through past videos. Get started on your quiz when you're feeling comfortable and ready. Now with this new schedule, we do have some extra time to submit things, so if you're feeling like you need an extra few hours, just get it in before the due date. Feel free to email me if you have any questions. Don't just jump into the quiz if you're not feeling ready. Make sure you really utilize the fact that now we have really a day and a half instead of 12 hours to get an assignment in. All right, email me if you have any questions.